In this lecture, we will be studying about a derivation tree. A derivation tree or parse tree is an ordered rooted tree that graphically represents the semantic information of strings derived from a context-free grammar. So we have already studied about context-free grammar and we have an idea about context-free grammars. And this derivation tree is actually a ordered rooted tree that shows the graphical representation of how strings can be generated from a context-free grammar. So it is also known as a parse tree, and now we will see an example to understand how this derivation tree is formed and what are the things that we need to know about a derivation tree. Okay, so here we have an example grammar given. The grammar is given like this: G equal to V, T, P and S. So these are the four tuples of the grammar, where V is the variables or non-terminal symbols, T is the terminal symbols, P is the set of production rules, and S is the start symbol. And then the production rule is like this: S gives 0B, A gives 1AA, and it can also give epsilon or the empty symbol, and B gives 0AA. So here S is the start symbol, the variables are B and A, and then the terminal symbols are 0 and 1. And then for this given grammar here, this is the derivation tree that is formed. So this is how we form the derivation tree for this grammar. Okay, so before we go into that, let us know the main things that we need to know about a derivation tree. The first one is the root vertex. The root vertex must be labeled by the start symbol. So the root vertex is the first vertex of the derivation tree, this one. So it should be labeled by the start symbol. Here our start symbol is S. The root vertex is labeled by S. And then the next one is the vertex. They are labeled by the non-terminal symbols. So the other nodes, this one, the vertex, these are labeled by the non-terminal symbols or the variables, which are A and B. So wherever you are seeing this A and B, these are the vertex. And then we have the leaves. They are labeled by the terminal symbols or by epsilon. So the leaves are the ending nodes or the ending vertices. Like for example, here we see that this vertex, it's a ending vertex, means this vertex does not have any more children. So those vertices which does not have any children, they are known as the leaves. So the leaves are labeled by terminal symbols or by epsilon. So we see that here this is labeled by 0, this is labeled by 0, this is labeled by 1, and these three are labeled by epsilon. So this is how we label the different vertices in a derivation tree. Okay, now let's see how this derivation tree is formed for this grammar. So first we start with the start symbol, which is S, and we see that S gives 0 and B. So we see that S gives 0 and B. These two vertices becomes the children of the root vertex S. And then we have B over here, and from B let's see what are the productions that we have. B can give 0, A, A. So B gives 0, A and A. Okay, and then this is a terminating symbol or terminal symbol, so you can leave it as it is. And then we have two variables A, and we see that A gives 1, A. So this A, I will say that it gives 1, A. So these are the three children of the vertex A over here. And also we see that A gives epsilon. So here I will just write that this A gives epsilon. And then now we are left with two A's here again, and since we want to end the derivation tree, we will say that A gives epsilon, because we see that A can give epsilon here. So this is how you form the derivation tree for a given grammar. Okay, and then there are two types of derivation tree that we need to know, that is the left derivation tree and the right derivation tree. Now we will see what are the left and right derivation trees, and we will try to see some examples to understand them. So here we have left derivation tree and right derivation tree. These are two types of derivation trees, and a left derivation tree is obtained by applying production to the leftmost variable in each step. Okay, and a right derivation tree is obtained by applying production to the rightmost variable in each step. So this will become clear when we take an example. So it actually means that whenever we are forming a derivation tree, if we apply the production to the leftmost variable in each step and then we move ahead, those are known as left derivation trees, whereas in right derivation tree we will apply the reproduction to the rightmost variables. So this will become clear when we take this example. So here we have an example which says, for generating the string AABAA from the grammar, S gives AAS and also ASS and also epsilon, and A gives SBA and also BA. So we have a grammar given here. This is a production of this grammar, and then we want to generate the string AABAA from this grammar. So let us see how can we make the derivation tree for this. So first let us make the left derivation tree for this, and then after that we will make the right derivation tree. Okay, so we start with the starting symbol, which will be the root vertex. So S is my start symbol, which is a root vertex, and then as we proceed, let's see, S can give the productions AAS and also ASS and also epsilon. So the string that I want to get is AABAA. So in order to get A, I will choose the production ASS from here, because I am not choosing this one, because if I choose this production, I am getting a capital A over here, and from capital A it is difficult to get a again in the next step, and I want to get A even in the next step. That is why I am choosing this one. So here I will choose this one, and so what will be the children that I will get for this root vertex? They will be A, S and another S. Okay, so I get this. Now this is a terminal symbol, so I can leave it as it is, and I have two variables over here, S and S. Now this is a left derivation tree, and I have two variables over here from which I can choose. And now since this is a left derivation tree, I should always choose the leftmost variable. So which is the leftmost variable? It is this one. This is to the left of this one. This is the leftmost, so I will choose this S. And let me see what production should I choose. I need to get the next symbol as A, and for that, what is the production of S that I will take? I'll choose the production S gives AAS, and why I'm choosing this is because if I choose this, I will get A, and then in the next step I need to get B. And since I have a capital letter A over here, we see that capital letter A can later give a B. So that is why I am choosing this one. So this S will give A and S. Okay, so this is what I get. Okay, now I am in this step, and again I have to choose the leftmost variable. And which is the leftmost variable? It is A over here. Now I have A, and then what is the next symbol I want? It is B, small letter B. So I already got AA and I need B. Now from A, if I want to get B, what is the production that I can use? A gives BA. So I'll choose this one. So this A will give B and A. So I get this one. Now I am done with this one, and there are no more variables in this step. So I go back to the previous step. Okay, so I go back to the previous step, and here that I see that I have a S, which is my variable, and I already got A, B, A. Now what I need is just one more A. So for that, what I will do is I will choose the production S gives A, S, S. That is because I'll get a A from here, and I'll have two S remaining, but I can replace those S with a empty symbol epsilon. So this S will give me A, S and S. Okay, this is an A. Okay, now we are done with this, and now I already got the string that I needed, A, B, A, this one. And now I am still having some variables and I need to complete them. I cannot just leave them like this. I'll again start with the leftmost, which is this one, S. And what should I do? I don't need any more symbols, so I see that S can give the production epsilon, which is the empty symbol. So I will say this gives the empty symbol, and I come to this one, which is the next. This also will give the empty symbol, and if I come to the previous level, everything is done. And if I come to this level, I see there is one S remaining. This also will give epsilon. So now we get the string that we needed, A, B, A. So A, B, A. We obtained this using the left derivation tree. Okay, now let us do the same thing using the right derivation tree. So for that, again I will start with the start symbol, which is S, and I will choose S gives A S S, just like in the previous step. A S S. Okay, now since this is the right derivation tree, I have to choose the rightmost variable in each step. So here I have two variables, and which is the rightmost one? It is this one. So now I have to start from here and not from this one like we did here. So I'll start from the rightmost. I have an S, and from S, what will I choose? I need to get this string. So just like we did here, I will choose S gives A S, this one. So S gives A and S. Okay, so I already have two A's here, and now I have to again fill up this using the rightmost variable, which is this S, and from this S I will again choose this production A S S. A S S. The productions we choose are almost same like the previous example. Okay, now I already got A, and let's say we got this A. Now I need BA. So in order to get BA, I have to choose the production which will give me BA, that is A gives BA. So what I will do is, I cannot directly go here, so I have to complete this. So how would I complete this? I don't want any more productions from this S. So starting from the rightmost, I will give the epsilon symbol to this S. Okay, and now I come up to this level and I have an A, and I want BA. So A gives BA. A gives B and A. Okay, and then this is done, and if I come here, I see that there is one S remaining. For this also I will give the epsilon symbol. Now we see that we got the sequence or string A B A A B A A. So this is how you do it using the right derivation